We need to solve the differential equation given by xy times derivative of y with respect to x equals to x squared minus y squared. Let us begin by rewriting this differential equation as derivative of y with respect to x equals to x squared minus y squared divided by xy. This is an example of a homogeneous differential equation because if we consider the function f of x y given by x squared minus y squared divided by xy, and we make the substitution x with lambda x and y with lambda y, then we get back our original function f of x comma y. Thus, when this particular criterion is met, we say that our given function f of x comma y is a homogeneous function. And because the function is homogeneous, this is going to be a homogeneous differential equation. Now, in order to solve this differential equation, we cannot here apply the method of variable separation because the function cannot be written as a product of two functions where one of the function is purely a function of x and the other function is purely a function of y. This is not the case here. So here we can however convert it to a variable separable form if we make the substitution y equals to vx, or simply put y over x is equals to v. Now if we take the derivative of this particular function with respect to x, so we have dy over dx equals to, apply the product rule, so this will become v plus x times dv over dx. So we'll use substitution as well as dy over dx and substitute into our differential equation, and this is going to give us v plus x times dv over dx equals to x squared minus y squared. So in place of y squared we have v squared x squared divided by x times y, so y will be v times x, so this is simply x squared times v. So we can factor out x squared from both the numerator and the denominator, so that will leave us with x times dv over dx equals to 1 minus v squared divided by v minus v. What we have done, we have taken the v from the left hand side to the right hand side. Now let's combine the two terms on the right hand side, so this will become 1 minus v squared minus v squared divided by v. We have x times dv over dx, or simply x dv over dx equals to 1 minus 2v squared divided by v, which can be also expressed as v over 1 minus 2v squared times dv equals to 1 over x times dx. So this is in the variable separable form. That's because the coefficient of the differential dv is purely a function of v and the coefficient of dx is purely a function of x. Now we can integrate both sides. Integrating will give us integration v dv divided by 1 minus 2v squared equals to integration dx over x. To integrate the integral on the left hand side, we will multiply the numerator with -4, and we are also going to divide it with -4. This is done so that when we use the method of substitution, 1 minus 2v squared equals to some other variable, it's going to give us the factor -4 in the numerator. Right. So this means we will have -1 over 4 times natural log of 1 minus 2v squared, and this will be equals to natural log of x plus the constant of integration, natural log of c. We have taken natural log of c because everything else is in terms of logarithm. What we can do, we can use the property of logarithm and take the -1 over 4 and write it as the exponent of the power of 1 minus 2v squared. So that means we have natural log of 1 minus 2v squared whole raised to the power of -1 over v. And we can combine natural log of x plus natural log of c, since the sum of the logarithm becomes natural log of the product of the two arguments. So this will be x multiplied to c. Now we can get rid of the logarithm from both sides. So this will give us 1 minus 2v squared all raised to the power of -1/4 equals to x times c. Now what we'll take, we'll raise it to the power of 4 on both sides. So this will be -1 and this will become x times c raised to the power of 4. Or simply 1 minus 2v squared will become 1 divided by x raised to the power of 4 times c raised to the power of 4. Now we finally make the final substitution, substituting the value v with y over x. So we have 1 minus 2 times v squared will give us y squared over x squared equals to 1 over x raised to the power of 4 times c raised to the power of 4. Let's multiply throughout with x raised to the power of 4. So we have x raised to the power of 4 minus x squared y squared equals to 1 over c raised to the power of 4. C is a constant, so 1 divided by c raised to the power of 4. This can be also treated as a constant, which we say is equals to a. So therefore, the solution x squared times x squared minus 2y squared equals to the constant of integration a. This is the required solution to our given differential equation.